Hi, my name is Dan Jitwood. I'm an assistant professor at Michigan State University in the departments of horticulture and computational mathematics, science, and engineering. Welcome to the fifth video tutorial of Plants and Python. Today, we'll be talking about pandas, data frames, and seaborn. The Python learning objectives are how to read in a data frame using pandas. Data frames have columns and rows, and we can refer to the columns by their names. We will learn how to quickly assess data frame properties using head and tail, how to select specific columns of a data frame, how to perform descriptive statistics using pandas like minimums, maximums, standard deviations, and value counts, how to mask data. This is a Boolean statement that we use to fish out data that we want. How to use the iloc function to isolate specific data from specific rows and columns in a data frame, and how to plot using seaborn, which is more specialized for statistics than matplotlib. The plant learning objectives are to set us up for the next activity. You'll see that CO2 levels are increasing and that this increases global temperatures. Plants respond to increases in CO2 and temperature. In the next activity, we'll be examining the effects of global warming on crop plants, and you'll see how statistics and data visualization are powerful tools to explore global trends. So first, let's learn how to read in a data frame using the pandas module. Pandas is usually imported as PD, so you press Shift-Enter to import pandas. And the most useful function in pandas is probably read CSV. This is a function that will take a CSV data and read it in as a data frame. Data frames have rows and columns the columns have names. By default, the files should be in your home directory, but you can also provide a path to it. So for example, I'll be loading in this data from my desktop, so I added /desktop and then the name of the file. So we hit Shift-Enter, and now we've created a variable data that contains our data frame. Now let's see how to look at our data frame using head and tail. So it's important to know what you're working with to see the data frame, and head and tail allow us to do that. So remember that the data is stored in the object data, and we use .head. And what we'll get is a preview of the first 5 rows, and we'll also get the column names. We can also use tail, and tail, if the head is the beginning, then the tail is the end. And you can see that we get the last rows in our data set. Tail is very useful to see just how many rows that you have overall. Remember that we're beginning with 0, so we have 714 rows or data points in this data set. Describe is a very useful function that gives you back summary statistics for your continuous variables. So if we use describe on our data, what we get is for running date, which was just from day 1 up to 714, a number that is increasing to keep track of day. Year is included as a continuous variable, even though we do not want it to be a continuous variable. And CO2 parts per million is, of course, a continuous variable. We get how many of each that we have. We have 714 of each. We get the mean of each, the standard deviation, the minimum, the quartiles at the 25th, 50th, and 75th quartiles, and the maximum value as well. So that's how to read in a data frame, how to quickly look at the data frame and get summary statistics of the continuous variables. Let's learn how to select specific columns of the data frame. If you remember, just in the previous example, that year was treated as a continuous variable. The data that you read in has the data from years 2017, 2018, and 2019, but we don't want those to be treated as numbers. We want them to be treated as a categorical variable, as if they were like year A, year B, or year C. So let's try to change our year column into a categorical variable. But to do that, we need to know how to refer to specific columns in Pandas. And this is extremely easy. This is one of the great things of using a data frame, is that you can simply refer to the columns by name rather than by an index number. So if we want the year column, all we do is for our data frame data, we have square brackets and we just refer to year as a string in quotations. If we want to set year to a categorical variable, we use the as type function to convert it into a string, which makes it a categorical variable. So we say for the year column, referring to it as a string, we want to convert it as type into string, and we set the year column back to a string referring to itself. So let's check that we were successful. And you can see now when we use describe that we no longer see year, because you can't take a mean or a minimum or a max of a categorical variable. We only have running date and CO2 parts per a million now. But this was to show you that you can access a specific column simply by referring to it as a string in square brackets for a data frame in Pandas. Next, let's look at how to perform some descriptive statistics in Pandas, things like finding minimums, maximums, standard deviations, how many there are of each factor level. And this is incredibly simple. You just saw that we can refer to a specific column using a string. Let's say we want CO2 parts per million, but we want the minimum value of CO2 parts per million for that column. So we refer to the specific column, and all we do is we add .min as a function. And we get back the minimum is 402.76. If we want the max, we do the same thing, .max. We get 415.39. If we want the mean, we just take .mean, we get 408, somewhere in between them. And if we want .median, we use the .median function. And we also get something somewhere in between the minimum and the maximum. There's a lot of these functions, and you can quickly look these up. They're very useful. You can use unique to give you the levels of a column, what types of different things are in that column. So for example, if we look at the specific column of month, the different levels of that column are the months of the year. You can also get how many things there are of each one. This is called value counts. Again, for month, maybe we want to get the value counts. And you can see for each month, it's going to give us how much data points there are for each month. There's a lot of really useful functions. Some of them even do plotting. For example, hist. Histogram will give you a histogram. And I have in here, I have to hit Shift Enter twice to get it. And then you can see that we get a histogram of the CO2 parts per million. So that was how, by very simply referring to the names of columns and then using functions in Pandas, you can get very basic statistical parameters back. Next, we're going to talk about something called masking. Masking is very important, and it's a way to find specific data that fulfills a criteria. And it's a Boolean statement. Remember, a Boolean statement is something that can only evaluate to true or false to find all the data in your data frame that is true with respect to the Boolean statement. So this is what masking does. It gives us specific data. And as I said, it's very simple. A mask is just a Boolean statement. So we say the mask is equal to, and then we have a Boolean statement. So for the data in the month column, the months, the Boolean statement is that it equals August. We use a double equals here because remember, when we're using Python, you can have less than or equals, greater than or equals, but equals is truly equal. So the Boolean statement is the month August true or false? That is the mask, and we're setting this Boolean statement equal to the mask. So we hit Shift Enter, and then we can see what the mask is. And what you see the mask is it returns the rows of the data frame that fulfill the criteria. So this is a large data frame, so it starts at the beginning, then it breaks, and then it goes all the way to the end. If you remember, the month of August was the very first data values. So you can see that these August dates, which were at the top of the data frame, are evaluating as true. But then they evaluate as false when the month is not August. We can get the full data back. So this is just all a mask does is it's returning for the rows which are trues and false. But if you put the mask within the data frame brackets, what you get back is the whole data frame, those rows of the data frame that evaluate as true. So for example here, you can see what we get returned is only data that is the month of August. These were the only rows that fulfilled the Boolean statement of being true, that they were August. So that's all the mask is. Remember, a mask is just a Boolean statement, and we put the mask in the brackets of the data frame to return those rows that evaluate as true for the Boolean statement. You can use this technique also with a specific column. So for example, if you say you're only interested in the CO2 parts per million values, that column, you refer to that column in the square brackets to get it, but you have a second set of brackets with the mask. And when you do this, you will have only returned the CO2 parts per million values, none of the rest of the data frame, because you specified this specific column. Usually you saw that we created a mask and we called it mask, and we were writing out the mask into our code, but usually people don't do that. They do it much more simpler, where they just write out the mask. This is the Boolean statement right here that I have highlighted, and they just put the mask all in one line of code with the data or the specific column that they want. This is a little complicated to look at, but always remember, go to the mask first, and it will be in the second set of brackets, or it will be in the first set of brackets, and it's just a Boolean statement, and it will return those rows that are true for the Boolean statement. And this is a way that you get specific data that you want. Next, let's look at another way to find specific data, and this is called the iloc function. And this is going to use rows and columns to find the data that you want. It's kind of like Excel, thinking of which rows, which columns that you want to isolate the data from. And you can, for both the rows and the columns, you can use indexing with the start, end, colon notation that you learned about before. So let's just review again what our data looks like. Remember, we use head for that. It just brings back the first 5 columns. But most importantly, it gives you the column names. And we can see that the first column is date, the second column is a running date, the third column is a month, the fourth is the year, and the fifth is CO2. So all you need to know about iloc is that the first position is rows, the second position is columns, and you can use indexing for rows and columns. So if we just use data.iloc and we just put in one number, it's the rows slot. Remember, indexing starts at 0, so this should give us back just the first row of data. And you can see this is August 13th, 2017, running date 1, August, year 2017, and parts per million 405.2, which is the first row of data. So rows and then the index give us the first row of data. Remember, -1 in indexing is a way to get the last element. And so if we do just -1, again, row position, and we get back the last row. And you can see it's the last row because it has the running date of 7/14. We can reference both rows and columns. So we could say the last row. And remember, if we just put a colon, which should have the start and the end, but we don't put any numbers, we're just going to get back all the values. So this will be the last row, but all the columns. And indeed, that's what we get. Last row 7/14, but all the columns, which is equivalent to just putting -1. But it also works this way because this is formally saying we want all the columns. In this case, with just an empty colon for rows, we're saying we want all the rows, but we just want the first column, the 0 index column. Remember, that's date. So we get all the dates because we asked for all rows of just the first column. We could also get all the rows for the second column. Remember, the second column is the running date. So that's, that is 1 through 714. You can remember, you can use indexing for both the rows or the columns. The indexing is inclusive of the start, but up to and not including the end. So in this case, we're saying we want rows 2 and 3 because we're going up to but not including 4. So this is rows 2 and 3 for columns of 2 to the end, which would be the third column to the end. So you can see we get rows 2 and 3, inclusive of start, up to and not including 4, rows 2 and 3. And we get the second index position of columns, which is the third column, to the end. You can use brackets separated by columns to get very specific rows and very specific columns. So what if you wanted index positions 0, 3, 5, and 7 for rows, and column positions 0, 2, and 4? And then you can see that's exactly what we get. We get the rows indexed by those random numbers, and then the first, third, and fifth rows of the columns, because remember, indexing starts at 0. So iloc is a very specific way to get very specific data by row or by column. Next, let's look at seaborn, which is an alternative way than matplotlib to look at your data. And as you'll see, seaborn is much more specialized for plotting statistical data than matplotlib is. So you've already seen how to use matplotlib before. You load in the module this way. But for seaborn, it works much better with pandas. As you'll see, it works much better with dataframes, and it can do very sophisticated statistical functions, and it's also a little more aesthetic in producing good-looking figures quickly than matplotlib is. So we import seaborn as SNS. Also, seaborn has this thing called styles, and you can use that using sns.set. And you can look up the different styles, and it's an easy way just to change, for example, the background, the grid lines, the axis ticks, and things like that in your plots that you make. So we hit Shift-Enter to import seaborn. And like I said before, there's many different, seaborn's very powerful, has many different types of plots and graphs and statistical analyses. And probably the best thing to do is to go to the seaborn gallery, and I'll provide this link in your notebook, and just look at the different types of graphs. And as you can see, there's a whole lot of different graphs here, and you can decide which graph that you want to make, and then you can click on it and see how you would go about getting this sort of graph. So I really encourage you to look at the galleries of seaborn. And I mentioned too, there were these styles. And so for example, the styles will change the background and the lines around the background, the grid lines, how dark or white the background is, whether you want tick marks or not on your graph. And also they have this very convenient thing to make figures for a paper or for a talk or for a poster, or for a notebook, which changes the size of the different elements depending on how large your figures need to be. So between the gallery and the different seaborn styles, there's a lot of different ways and techniques to create beautiful plots and do statistical analysis using seaborn. So one of the most common seaborn plot functions is called lmplot. So we call it by SNS lmplot. And this is how easy seaborn is to use. Just by referring to your data frame, saying data equals what your data frame is, in our case it's data. As soon as you tell seaborn what the data frame is, you can refer to your data by column name. So let's say we want a linear model plot using lmplot, where the x-axis is the column running date. and the y-axis is CO2 parts per million. And we say that our data frame is data. And really quickly, Seaborn will come up with this beautiful plot. You can see the data here. You see this cyclical cycle of CO2 parts per million. This happens every year. It has to do with the seasonal variation of the Earth. And this is literally because the plants are dying in the winter in the northern hemisphere, and vice versa in the southern hemisphere. And the amount of carbon dioxide that they're taking in and releasing and decay and other things that contribute to CO2 create these really striking cycles. This data, if you remember, is from 2017, 2018, 2019. And even though it's cycling up and down, the overall trend is to go up. So the linear plot function refers to linear modeling. And so it will plot your data as a scatter plot. As you can see with these points, these are the CO2 values, right? As we specified for our y-axis, but it will automatically try to fit a line to your data. A line is not appropriate for the cyclical nature of this data. As you can see, you would have to use something like a sine function for that. But you can see because the CO2 level is increasing overall, that the linear function is appropriate for looking at that overall increase. Let's say, though, that we just want the scatter plot. We don't want a line in it. So you can just run the same line of code with lm plot, but this fit reg argument is should Seaborn try to fit a linear model, and you can say false. So if you say false, then you just get the scatter plot of CO2 parts per million back. Another really great function in Seaborn is dist plot. This is like a density or a histogram plot, and you just say which column you want to create the density histogram plot of, and we want to look at CO2 parts per million, and you'll get a beautiful histogram. But importantly, you're getting this density estimate of the distribution of the data as well. Let's say that we want to be more specific. We want to look at the different densities of the year 2017, 2018, and 2019. So remember, we already converted year into a categorical variable, but we can create masks. So we're going to say we want the CO2 data, right? So we refer to the CO2 column as a string in the brackets, and then we put a second set of brackets with our mask. We say we want all the data for CO2 for the year 2017. So we say where it's true that year is equal to 2017. And we create a object to store that data, and we call it year 2017. We do the same for the year 2018, and we do the same for the year 2019. So now we have our years separated out. We used masking, and it's just like matplotlib. You can just keep on calling the plotting functions one after the other, and they will just paste the data on top of the plot that you're making. So we want a density plot of the year 2017 CO2 values, a density plot of the year 2018, and a density plot of the year 2019. And you can see, whereas we had them all combined before, now it's creating these different density plots. And we can see there's clear differences in the CO2 levels between years, and that they are increasing. So what did we learn? We learned how to read in data as a data frame using Pandas. Data frames are specially organized data that has rows and columns that you can refer to by name. We learned how to quickly assess data frame properties and just look at the data frame using head and tail. How to select specific columns of a data frame just by referring to the name as a string. How to perform descriptive statistics in Pandas with a host of very useful functions like minimum, maximum, standard deviations, means, medians, etc. We learned how to mask data. This is a powerful way to try to find specific data that fulfills a criteria. We do that using a Boolean statement to find the data that fulfills the Boolean statement as true. Another way to get specific data is using the iloc function. And this is a way to using indexing to refer to specific rows and columns to isolate specific data. And then we learned about visualizing and plotting our data with seaborn, and that seaborn is a lot more powerful than matplotlib with respect to using data frames, the ease of referring to specific columns, and also specialized plotting for statistical things such as linear modeling, density plots, and things like that. The plant learning objectives are that CO2 levels are increasing, and this is increasing global temperatures. Plants respond to increases in CO2 and the subsequent changes that occur in temperature, precipitation, and other environmental changes. In the next activity, you're going to examine the effects of global warming on the harvest dates of grapevines across multiple centuries. And statistics and data visualization are powerful techniques to look at large global trends like climate change. So that's all for this video. Thank you for listening.